Okay, 3, 2, 1, 0, here we go. Kelly's going to find a problem date, and we are going to do some trigonometry. So the last little bit that we need to look at is simplifying trigonometric expressions as well as solving trigonometric equations. This usually goes well for students. And by the way, I didn't put up the score breakdown, but I think over half the class got either a 25 or a 26 out of 26 on this last test. So you guys performed very well, so way to go. Okay. This is important that you frame this in your mind properly. Some of you will look at this and you'll immediately think negative. Be like, oh shoot, this is going to be hard or impossible or this looks new. It's not that bad, but it might look bad at first. Okay? So just trust me when I say we can figure this out. Just be a little bit patient. Okay? We're going to take 2 days to do this first lesson. And we start with just some basic notes. And our notes that we want to write down is this. If you remember when we were in the unit circle and we came up with a coordinate x, y on the unit circle, we said that sine was equal to something and cosine was equal to something. And we also said that tangent was equal to something. Do you remember if we had a coordinate x, y, do you remember what sine was equal to?
Y.
It was equal to the y value. Do you remember what we said cosine was equal to?
X.
It was equal to the x value. And tangent was equal to? Y divided by x. Now what's interesting about that is if you see if cosine is x and sine is y, then wouldn't tangent just be sine divided by cosine? So that's the first piece for today, is that tangent is sine of theta divided by cosine of theta. The second thing I want you to know is that cosecant, CSC, it means cosecant, that's the reciprocal of sine, 1 over sine of theta. I also want you to know that cotangent is the reciprocal of tangent, so it's cosine of theta over sine of theta. And then finally, I have secant of theta, which is the reciprocal of cosine. It is 1 over the cosine of theta. You don't need to memorize any of those. Those will all be given to you on the test, but you need to make use of them. I want you to box those. Draw a box around those. And draw a box around those. We are going to use those today. That's our essential information that we're going to make use of. Can I show you what we are not going to make use of, but is still kind of important in trigonometry? Tangent and cotangent are reciprocals. So therefore, tangent is the same as 1 over cotangent, and cotangent is 1 over tangent. But you will not use those today. We like to use the ones that involve sine and cosine. So just to be clear, can everybody see that you have 2 of these equations that say tangent equals? We like the one that involves sine and cosine. We don't like the other. Are we good with that? Okay. And then we also know that sine is the reciprocal of cosecant and cosine is the reciprocal of secant. So we have 1 over cosecant and 1 over secant. We are not going to use those 2 today. We're going to use the other ones that say cosecant equals and sine equals. Or in secant equals. Wow.
I don't know what that noise was.
Cat coughing up a fur ball.
It was something.
Oh, which by the way, as we kind of get into this piece, but just a side note for a second. Has anybody seen the artificial intelligence put forth by Google called Gemini? Mm-hmm. So it was just released. And so Mr. Luther sent me a picture this morning on Gemini. He said, I have a box or a dog that I'm very attached to, and I coach pole vaulting. And so he said, Gemini, paint me a picture of a boxer pole vaulting. And it came up with something. So he came in this morning, he was really excited. He's like, what do you want to draw? I said, I want to draw a goat doing mathematics. And so,
That's Mr. Gens, literally in middle school.
like, what do you guys think? Like, I think it's pretty good.
I love that.
I think I should print it out and frame it, get it in the room.
Honestly, I think
You
so.
know?
Put it on the back wall.
That's pretty good. What I like, look at the pencil. It's not like the goat is able to hold the pencil with a thumb. It's like the pencil's actually going right through the hoof, like it was like impaled or something. It just like grew around it now. He's even got kind of a smile. He's like,
What
hey.
happens when he has to sharpen his pencil?
I know. I think he uses his teeth, is what he does. You know, goats will eat it about just about anything. But yeah, it kind of, I don't know, I'm kind of inspired by it. So I think it's pretty good.
Yeah,
So, that was cool.
Put it on the back wall.
Yeah.
Need some color.
All right.
Get a tapestry.
So, right now we are just going to investigate 5 problems, and then we're going to be done for the day, and we're going to reinvestigate tomorrow. But just stay with me step by step. The first way in which we like to simplify trigonometric expressions is we like to write things so there's only sine and cosine involved. So notice this says sine of theta times secant of theta. This can be simplified. And when I say simplified, don't write this down, but say you had 4x squared over 6x. Can that be simplified? Yeah, the 4 and 6 are each divisible by 2, so you get 2 over 3, and one of the x's cancels, so you get that, right? That's kind of what we want to do. So you can see how it unfolds here. The first thing I'm going to write is I'm going to write sine over 1. And instead of secant, what am I going to write? I'm going to write this thing. I'm going to write 1 over cosine. So I have 2 new fractions, and I'm going to multiply the top, and I get sine times 1 is sine. And on the bottom, I get 1 times cosine is cosine. So it turns out that sine times secant is the same as sine over cosine. Keaton, what is sine over cosine?
Tangent.
It is tangent.
Wow. Do we have to write the theta?
Yes.
I saw a TikTok and it was like knowing sine over cosine is what I'm gonna be on spring break.
Yep.
Tan.
There, now you get the joke.
Yes.
Yeah. All right, the next one. Instead of cotangent, what am I going to write?
Cosine over sine.
Cosine over sine times sine over 1. What happens when I multiply those two together? The sines cancel, don't they? And you're left with cosine on top and 1 in the bottom, which is just cosine.
Never in my life would I thought the math problem had COS, a circle with a line through it.
Yeah. So it kind of in that part now where numbers kind of start to go away a little bit. We're going to bring numbers back here in a little while next week, and you'll like that when we solve equations. And trust me, as we spend more time with this will feel more comfortable, okay? Look at the next one. Instead of cotangent, what will I write?
1 over cosine.
Cosine over sine.
Oh, where? Oh, you went down.
Yeah, I'm sorry, I'm going to skip letter C. I don't like that problem. And instead of secant, what would I write? 1 over cosine. So as I multiply these, what's going to happen? The cosines do reduce. Am I left with sine over 1, or am I left with 1 over sine? And what is 1 over sine? Cosecant. I want you to try letter E on your own. You can do it. You are super smart.
So do we have to put one of them on the line?
Both of these, The cosecant will be 1 over something. All right, I've got sine over cosine times 1 over sine. What cancels? Sines reduce. And I'm left with 1 over cosine. Do I leave it like that? What is 1 over cosine? It is secant. So it kind of looks like magic, but the fact is if we just use those 4 formulas up at the top, it's really not that bad, is it? Hi.
Why don't we use the other ones again?
Excellent question. Okay, as I move back up here, I just want you to know that what makes these special is that they all can be rewritten in terms of sine and cosine. They can all be rewritten in terms of sine and cosine. If you notice, that allows things to cancel. If we used the ones that I'm going to mark in black, those won't, they're not as relatable, so they don't necessarily cancel. Get my point?
Yep.
Okay.
Are we gonna use those when numbers start popping up?
Nope. It's hard for me as a teacher to say tangent is sine over cosine and cotangent is cosine over sine, but not write down the fact that those are reciprocals of each other. I mean, it's like, that's just something you just kind of keep in your head. Like, these are just things you're like, okay, yeah, we know that these two are reciprocals. This is what we use to rewrite. Okay? All right, our last one. What's different about this one?
There's 3.
There's 3 of them. And so I'm going to rewrite secant as
1 over cosine.
1 over cosine times 1 over sine times
Cosine over sine.
all right, what's going to happen?
The cosines are going to cancel out.
The cosines do cancel out. What do I have in the top?
1.
What do I have in the bottom?
2 sines squared.
Sine squared.
Yes.
Now, this is an important note. I think that this is sometimes we get our classes confused. I teach 3 different math classes, but if we take sine of theta and we square it, what that means, that's what that means. The way we write it mathematically is sine squared of theta. We don't put the squared on top of the angle because then people think we're squaring the angle. But these two things mean the same thing, okay? So it's 1 over sine squared of theta. Think I'm done? What's the reciprocal of sine?
Cosecant.
So it's cosecant squared of theta. What do you think?
Ain't bad.
So tomorrow we'll practice with a couple problems. Yes, sir.
Why do we have to do that, the cosecant from the sine squared?
So if you ever see in this situation, just notice you have a 1 over sine. Right up here it says 1 over sine. That could be simplified to cosecant. So if you ever see a 1 over sine or cosine, make it a cosecant. Okay.
Gotcha.
All right. So don't worry about starting your assignment. You're going to start that tomorrow. We're going to pick up and do a little bit more. You guys have a little bit of time to visit before class is over.